Hello dear students, hope you are all doing well. I'm back again with another video lesson. In the previous lesson, we studied the types of the generator. If you remember, we studied that we had two types of generator, AC generator and DC generator. And we studied the AC generator that produces alternating current. What do we mean by alternating current or AC current? A current that it is magnetic and direction changes as a function of time, or it is direction and magnitude changes continuously. In AC generator, a generator gives us a current that it is magnetic and direction changes continuously. So the component of the generator, we have magnetic field, conducting loop, two slip rings, and two graphite brushes to maintain the contact between the external circuit and the internal circuit of the loop. So we studied here in DC generator. The second type of generator is DC generator. So what is DC generator? A generator which produces a direct current, direct pulsating current. Okay. So the component of DC generator is like this. We have a magnetic field. Okay, this is magnetic field, north, south, and it has a magnetic field from north to south. Okay, the component of the DC generator, magnetic field and conducting loop of wire, conducting loop, and we have a single split ring, half insulated ring or commutator. The difference between DC generator and AC generator only in commutator. In AC generator, we don't have commutator. We don't have single split ring. And instead, we have two slip rings. But in DC generator, instead of two rings, we have only one ring. But this ring, there is a gap between this ring. Okay, the ring is separated into two parts, two half rings, which is called commutator. So what is this? This is commutator. And such as AC generator, we have graphite brushes, okay, connected with the galvanometer to indicate the amount of the current. So this is basically the component of the DC generator. We have magnetic field. We have four components: magnetic field, conducting loop, commutator, and two graphite brushes. What is the difference between AC generator and DC generator? Only in commutator. In DC generator, we have commutator, but in AC generator, we don't have commutator. So in DC generator, the generator gives a current, only it is magnitude changes, not direction. The current of DC, guys, only magnitude changes. If you see, the current all the time is positive. We don't have the negative part of the current. Why? Because in DC generator, only the magnitude of the current changes. How? What is the value of current here? 0. Here maximum. Here 0. 0 max, only magnitude changes. We don't have negative. The direction of induced current in the DC generator doesn't change. It's constant. But it is magnetic, changes. The component we studied, okay? What is commutator? A single split slip ring like this. If you have, this is single ring, okay? Like if you separate this ring into two half rings, it's gonna be like this. Now, how many half rings do you have? Two. The single split rings, okay? This ring is split into two parts. There is a gap between these two half singles. There is what? A gap between these two half singles. This is called commutator that can be used in DC generator that prevent the reverse of the current of induced current in DC generator. Okay, because of the commutator, the current does not go into the negative part. Okay, because of this commutator, because of this gap. Okay, as you can see here, the current cannot flow into the negative direction. Okay. Commutator, a single split slip ring formed of two insulated halves which convert AC to what? To DC. How can you convert AC generator to DC generator? By adding commutator instead of two slip rings. So another type of current is DC battery. The DC of battery, the direction and magnitude doesn't change. For example, if the maximum current here is 10 ampere, the current all the time is 10 ampere. Okay? In DC battery, guys, in DC battery, neither magnitude nor direction of the current changes. The magnitude and the direction of the current stay unchanged or constant. Okay? In DC generator, the magnitude of produced current can change, but its direction doesn't change, does not reverse. The current produced is often referred to pulsating directed current. This current is called pulsating directed current. We can convert AC generator to DC generator. How? By removing the two slip rings and replacing what? Commutator. Okay, and adding commutator half rings, which prevent the reverse of the current every half cycle, resulting in pulsating directed current. A steady directed current can be produced. When does the steady directed current can be produced? With the little pulse, if you use many loops and many commutators. Guys, what is the difference between these two, these two currents? Okay, this is DC pulsating current. Okay, but in this case we have only one commutator. How many commutators do we have in this figure? We have one commutator and one loop. But if you see this with a little pulse, we cannot say this is perfect directed current. This is not perfect directed current, guys. In DC generator, we cannot produce a steady or 100% directed current like battery, but we can produce a current with a little pulse, not with a more pulse. Okay, here we have more pulses, so that is why we have one commutator, but we have one loop. So the commutator is like this here. Look. Guys, we have one commutator. It means that we have only one gap. Okay? But in this figure, also this is DC pulsating current. What is this? DC pulsating current still. But what is the difference between these two figures? This is with the more pulse and this is a little pulse. When does we can achieve the little pulse induced current in DC generator? If we use many commutators and many coils. We have many commutators and many loops. Okay, we have many commutators and many loops in this figure. So what I mean by many loops, it means that many commutators, we have more gaps. Okay. Okay, we have many gaps, it means that many commutator. If the commutator, it has more gaps, it means that the pulsating decreases. Okay, the DC generator can become a little pulsating current. A steady directed current can be produced by using many loops and many commutators. What is the purpose of many loops and many commutators? To produce, and in order to produce a current with a little pulse. This is around the rotational axis of the AC generator. A current is then produced that is almost constant with a little pulse. With what? With a little pulse. Resistor can be used either alternating current and DC current. Doesn't matter the source is AC or DC. Resistance can work with both AC and DC. When we say resistance, it means that the light bulb, guys, the light bulb acts as a resistor. Can be used with the AC source and with the DC source. Why? Because the resistance does not depend on the frequency, does not depend on the direction of the current. It goes to the negative, positive, decrease or increase. It depends on what? It depends on the amount of charge that flows by the potential difference. It doesn't matter the potential difference is AC or DC. Okay? So When we say resistance, it means that light bulb, okay? Or resistance this is resistance. This resistance can work with DC source, DC battery, or AC battery. If you have a light bulb with both sources, the light bulb will glow, DC or AC. Either alternating or DC. What is the function of a commutator in DC generator? Convert AC generator in one direction into DC generator, okay? Changing current in one direction, only DC generator pulsating directed current. What is the function of the two brushes in electric generator in both DC generator and AC generator? They maintain continuous electrical contact with the commutator or slip rings in AC, allowing the flow of electricity while the rotor rotates. What is the purpose and the main of using many loops and many commutators? As we studied, by using many loops and many commutators, we can achieve a current with the little pulse. But if you use one commutator on one loop, so the pulse will be more, okay? You probably see the direct current with a little pulse. Question 16, how can AC generator converted to DC? Replace the slip rings with commutator. Replace what? The slip rings, the two slip rings with commutator, which prevents the reversal of the current every half cycle. The faster the coil of the loops or armature of an AC generator, okay, rotates, the harder it is to turn the loop. Why? Why? As the rotation of the coil in generator increases, as the angular speed increases, the rotation of the coil increases, it becomes hard to turn it. What is the reason? According to Lenz's law, because as the angular speed increases, what happened to the induced EMF? As omega increases, what happened to EMF? EMF also increases. When EMF increases, what happened to the current? Current also increases. So this current, induced current, opposes what? Induces what? Induces magnetic field. Okay? Induces what? According to Oersted? Induced magnetic field. So this induced magnetic field opposes what? External magnetic field. External magnetic field. Because of this opposing of external magnetic field, that is why it becomes hard to turn the rotor and the coil or the armature of the conducting loop. This is the reason. Once again, listen carefully, guys. The question says, the faster the coil of loop or armature, faster coil of loop, it means that when omega increases. When omega increases, what happened to the EMF? EMF also increases. When EMF increases, what happened to the induced EMF? Increases. Induced magnetic field also induces. This induced magnetic field opposes what? External magnetic field. Why? Because in generator we have two fields. The permanent magnetic field of the bar magnet or external magnetic field, and the induced magnetic field when the current passing through the conducting loop. According to Oersted, this current can induce a magnetic field. Now, how many fields do we have? Two. These two magnetic fields, according to Lenz, though they are opposite to each other, so that is why it becomes hard to turn. The answer, the magnetic field of induced current, which means that this magnetic field opposes what? The change in what? External magnetic field. This is external magnetic field. Okay? Faster rotation of the coil increases this induced current and opposite fields. A generator produces a continuously changing EMF. AC generator, the magnitude of EMF changes continuously. So at mark A, B, C, D. At A and C, EMF 0. Induced current 0. Plane of the loop perpendicular. Plane of the loop perpendicular. So this is very important. Pay close attention, please. Guys, be with me with the full focus. At mark B and D, as you know, potential difference maximum, current maximum. At letter B and D, EMF maximum, I maximum. Plane of the loop, when we say plane of the loop, perpendicular, plane of the loop, plane of the loop. Perpendicular to what? To the magnetic field. But here plane of the loop is parallel to the magnetic field. To what? To the magnetic field. Okay? The orientation between the magnetic field lines and the normal to the loop, the following equation for the EMF produced by generator can be derived from Faraday's law. Okay? Guys, for the generator, EMF is equal to what? EMF is equal to NAB omega sine omega t. What is this? This is the equation of induced EMF in generator. In what? In generator. How can you recognize this equation? If in the question says the generator or the angular speed or frequency is given in the question, you have to use this relation. Guys, this equation is based from what? Or derived from what? From Faraday's equation. This equation derived from what? Faraday's equation. Change flux over what? Delta T. The derivation or the derivative of cosine theta as a unit of, as a function of time. How? Now I'm going to prove for you. But this proof is not required for the student to know and not describe it in this book. Okay? But I'm going to prove for you and to learn more about how can how can we get this equation of generator. Okay? Guys, as you know, flux is equal to what? AB cosine theta. EMF and A, B, cosine theta, here unit of what? Time. If you, the derivation of cosine theta, N, A, B, cosine theta is equal to what? Omega t. D over dt, the derivation as a function of time of what? Cosine theta, cosine omega t. The derivation of cosine omega t is going to be what? Negative n a b. The derivation of cosine is what? Negative sine. It becomes what? Omega negative sine omega t. EMF is equal to what? Negative times negative positive. N, A, B, omega, sine omega t. So the equation of generator of induced EMF and current in generator is based or derived from what? Faraday's equation. So we can say this equation is also the Faraday's equation but for generator. Okay? So according to this relation for generator, NAB omega sine omega t or sine theta, guys, theta is equal to omega t. Why? Because omega is equal to what? Theta over time. We studied in chapter 1, angular displacement, angular speed is equal to angular displacement period of time. Guys, for one complete cycle, for one full revolution, one cycle, one complete cycle, theta is equal to how many rad? 2 pi. Period for one cycle is equal to what? T capital. 2 pi. Period is equal to what? 1 over f. Reciprocal according math basic, it's gonna be what? 2 pi f. Okay? So omega is equal to what? 2 pi f. At the same time, why theta is equal to omega t? Omega theta over t. Theta is equal to what? Omega times t. Instead of sine omega t, can we write down sine theta? Yes, absolutely, you can write down this. Okay? Guys, if theta or omega t is equal to 90. Sine 90 is equal to 1. EMF becomes what? Maximum. N, A, B, omega. Don't write sine 90 because sine 90 already is equal to 1, maximum value. Okay? What does maximum EMF depend on? Number of turn, area of the loop, magnetic field, angular speed. Okay? So this is angular speed, frequency, angle between magnetic field and the normal to the loop. What does the maximum magnetic induced EMF depend on? We studied this fact, 4 factors. What does frequency of 50 hertz mean? When we say frequency is equal to 50 hertz, what do you mean by this? When we say frequency is equal to 50 hertz, what do you mean by 50 hertz? It means that this current 50 times up and down in 1 second. Okay? 1, 2, 3, 4 until 50. Why? Because frequency is equal to number of vibration per unit of time. If the current oscillated 50 times per 1 second, 50 times 1, frequency is equal to 50 vibration is equal to what? Is equal to 50 hertz or 50 1/2. So this is mean the frequency. When we say frequency 50, it means that the current or voltage alternates 50 times. How many times? 50 times per second. The 4 locations here, as indicated in this figure, guys, we studied. The 4 location marked on this curve, A, B, C, D, at which mark the maximum EMF and maximum current. We have maximum current and maximum EMF are letter B and D. In a mark B and D, we have maximum EMF and maximum current. So how the coil oriented in B and D? Plane of the loop, parallel. Plane of the loop, parallel to the magnetic field. But at C and A, plane of the loop is perpendicular to the field. When plane of the loop is perpendicular, angle is equal to 0. Sine 0, 0. EMF 0. Current 0. Why? Because the equation of generator NAB omega sine omega t, guys. Sine 0, 0. Sine 180, 0. But sine 90 maximum. When plane of the loop is parallel, theta is equal to what? 90. Sine 90 is equal to 1. EMF maximum. Current maximum. At location A and C, current and EMF 0. Plane of the loop is what? Perpendicular. Angle 0 to the magnetic field. The angle of the normal is 0. When we say plane of the loop perpendicular, the angle of the normal is parallel. At location B and the EMF maximum, plane of the loop parallel, angle 90. The angle of the normal to the magnetic field is 90 degrees. Okay? Okay. Guys, when plane of the loop is perpendicular to the magnetic field, like the segment A and C moves parallel to the magnetic field, B and B is parallel. Guys, look. This is generator, okay? North, south. This is magnetic field. When the plane of the loop is perpendicular, When plane of the loop is perpendicular, the segment A and B is parallel. The movement of this wire is moving parallel to the direction of the field. Okay? These two segments are parallel. The movement of this wire is moving parallel when plane of the loop is perpendicular. In this case, plane of the loop perpendicular. Perpendicular. When plane of the loop is perpendicular, angle is 0. Okay? So the segment, the movement of this wire, parallel. V parallel with what? With magnetic field. When V and B parallel to each other, magnetic force equal to 0. Why? Because magnetic force is equal to Q, V, B, sine theta. This angle is the angle between V and B. If V and B parallel to each other, 0 or 180, magnetic force becomes what? 0. When magnetic force is 0, EMF, 0. Current, induced current, also 0. Okay? If someone asks you why when the plane of the loop is perpendicular to the magnetic field, EMF 0, current 0, even the maximum field crosses the loop, because the change of the magnetic field is 0. Why change of the magnetic field is 0? Because the segment A and C is parallel. The wire here is moving parallel to the direction of the magnetic field, and magnetic force becomes 0 because when V and B parallel to each other, angle between them is 0, and sine 0 is 0, magnetic force is also equal to 0. But in the case when the plane of the loop is parallel to the direction of the magnetic field, in this case the angle between the normal and the magnetic field becomes perpendicular, and the segment A and C becomes perpendicular to the magnetic field. Magnetic force becomes maximum because magnetic force is equal to QVB sine theta. Angle between V and B is perpendicular. Sine 90 is maximum. Assume that when this is magnetic field, north, south, okay, and okay, guys, as we know, when the plane of the loop is perpendicular, the angle between V and B is parallel, 0 or 180, the magnetic force 0, and no current induced, and no magnetic field, no magnetic force induced. Guys, when the plane of the loop is parallel in this time, okay, if the plane of the loop is parallel, when the plane of the loop is parallel, the segment of A and C, angle between V and B becomes perpendicular. Look, as the plane of the loop is parallel to the magnetic field, no magnetic field lines crosses the loop, but induced EMF is maximum. Why? Because as the loop rotates and it becomes parallel to the magnetic field, as the loop reaches, like the plane of the loop is parallel to the magnetic field, the magnetic flux, change in magnetic flux becomes maximum. Okay? So the angle between A and V, the velocity and B is perpendicular. Okay? When V and B is perpendicular, magnetic force is equal to QVB sine theta. Magnetic force becomes what? Maximum. Why? Because angle between V and B is 90 degrees. Sine 90 is maximum. When force is maximum, this force, it goes to induce the current and EMF in the loop. So EMF reaches maximum, current also reaches maximum value. Why, when the plane of the loop is parallel, no magnetic field crosses the loop, but induced EMF and current is maximum? Because magnetic force is equal to maximum when the plane of the loop is parallel. When the magnetic force is maximum, induced EMF becomes maximum and current becomes maximum. Here in this figure, plane of the loop perpendicular, VB parallel, EMF 0. Why? Because magnetic force 0. But when plane of the loop is parallel, angle between V and B is perpendicular, magnetic force maximum. Okay? So EMF maximum current is also maximum. And because the segment A downward through the field, while segment C moves upward, their EMF in opposite direction, but both for this is counterclockwise current. Okay, in the figure B, the direction of the current is counterclockwise, but in figure D, the direction of the current is clockwise direction. A student turns the handle of a small generator attached to a lamp socket containing 15 watt. The power that dissipated in the bulb is 15 watt. The bulb barely glows. What should the student do to make the bulb glow more brightly? When does the bulb glows more brightly? When current increases. When current increases, what happens to the brightness? Brightness also increases. When does the current increases? When EMF increases. When does the current increases? When EMF increases. When does EMF increases? When angular speed increases. EMF is equal to what? NAB omega. As the angular speed, the handle of the generator, if turned faster and faster, omega increases. When omega increases, EMF increases. When EMF increases, current increases. When current increases, the bulb glows more bright, okay, and becomes more brightly. What is meant by term frequency in reference of alternating current? What do you mean by frequency in alternating current? Frequency, what is the frequency indicates how often in each second the current goes from maximum value in one direction to the maximum in other direction and back. Okay? When a plane of the rotating globe of the wire is parallel, when the plane is parallel, as you can see in this figure and this one. When plane is parallel to the magnetic field, when we say plane of the loop parallel to the magnetic field, angle is perpendicular between B and B, okay? The number of line passing through the loop is 0. No field line crosses the loop. Why is the current at maximum at this point? Guys, as we studied here, as the plane of the loop parallel, force becomes what? Maximum. When force is maximum, EMF also maximum, and current also becomes maximum. The magnetic forces are greatest or maximum on charges in the side of the loop that move what? Perpendicular. V and B perpendicular. V and B perpendicular. Okay? When plane of the loop is parallel, V and B becomes perpendicular? Yes. We have three figures. Which figure acts as a generator? Absolutely figure A and B. Why? Because in figure A and B, the shaft attached at the end of the coil. The shaft attached or fixed with the coil. Here is also fixed with the coil. But here, the shaft is not fixed with the coil, with the sides of the coil. Okay? The shaft fixed in another way. And here, the field is rotating, the magnetic field or the magnetism rotating along the loop. But here, the magnetic field crosses the field, so that's why figure A and B act as a generator. A and B, the magnetic field lines, this case is plane perpendicular to the plane loop, so the loop crosses the magnetic field lines. Frequency of the alternating current can differ from country to country. It depends on the country. For example, in the United States, Canada, and Central America, the frequency of the rotation chimerical generator is 60 hertz. But the United Kingdom, Europe, and Asia, some of the countries in Asia, they are using 50 hertz. What do you mean by 50 hertz or 60 hertz? It means that 50 times the current moving up and down in 1 second. Number of vibration per unit second. Omega is equal to what? 2 pi f. Why? Because why omega is equal to 2 pi f? This equation is based from what? Omega is equal to theta over time. For one complete cycle, how many rods do we have? 2 pi rods. For one complete cycle, time interval is equal to what? Period. So, period is equal to what? 1 over frequency. Reciprocal by math basic, it's gonna be 2 pi f. Okay? When frequency is given, you can find and determine the angular speed. So, the resistor can be used, as we studied, either alternating or directed current. A resistor resists the motion of the charge regardless whether they move in one direction or shift direction periodically. It doesn't matter the direction of the current change or no change. Resistor can be used with both AC and DC. The magnitude of alternating change from positive to negative. As a result, the output current from generator changes its direction on regular intervals. This variety of current is called alternating current, AC current. Guys, for one complete cycle, both magnitude and direction of the current changes. One full cycle. But for half cycle, only magnitude changes. Direction doesn't change. From 0 to max to 0. Okay? That's all for today. Inshallah, in the next lesson, we will study the motors and mutual inductance, and inshallah we will be finished the section 2 in chapter 6. Thank you for listening. Hope you get benefited from my lesson. Keep up your best doing.